Hi there. Today we're going to be looking at the functions lab, and let's get started with it, okay? So here it says write a function called introduce myself that prints a brief introduction of yourself. Call the function and observe the printout. So let's see how we could do that. So to create a function, we start with the keyword func, and I'm going to call the function introduce myself, okay? And we put the two brackets and we put the curly brace, and inside here we're going to print a string that introduces myself. I'm going to say hi, my name is Mr. Baram. I'm going to close the string, and that's pretty much my function. So now I've created a function that prints out hi, my name is Mr. Baram. To call up the function, I simply write the name of the function, introduce myself. And once I call it out, it should print out at the bottom here, my name is Mr. Baram. Okay, perfect. Okay, the second thing that we have to do here is says write a function called magic 8-ball that generates a random number and then uses either a switch statement or if statement to print different responses based on the random number generated. Let random num equal arc for random underscore uniform UI int 32 5, and this essentially is the code to create random numbers. And this will generate a random number from 0 to 4. Why? Because I've said in here it said go up to 5. 5 is the limit. So if you put 9 here, it'll generate 0 to 8. If you put 105, it'll generate 0 to 104. So this is the limiting number that will never be reached. And this function right here that's built into Swift generates random numbers with an index of 0. So it always starts at 0. After which you can print different phrases corresponding to the number generated. Call the function multiple times and observe different printouts. Note that the random number generation will not work unless your function is declared after the import foundation statement below. This is because the arc random underscore uniform function is declared in the foundation framework. So this is just a different type of framework. So they've already printed for us here import foundation, which is great because we would need the foundation framework for this function to work. So we're just gonna leave that, and then we're gonna do what they told us to do. So we're gonna create a function called magic 8-ball, and obviously create the brackets, and then create the curly brace, and our function is going to go in here. Okay, so what do we do here? Well, it said here create a constant called random num. So let's do that. So let random num equal arc for random underscore uniform, and then it says what's your upper limit here. So we're gonna do UI uint 32 like they told us to, with a limit of 5 like they told us to. Okay, so I just copied this line of code from here, and this essentially what this line of code does is it creates a random number from 0 to 4, and it stores it in this constant called random num. Okay, great. So next up, we have to create a switch statement or an if statement. I'm going to create a switch statement here. So switch random num, okay, and what we're going to do here is we're going to say for case 0, right? Because if the random number is 0, we're going to print so this is a magic 8-ball, right? So we're going to say I don't know, yes, go for it, right? If it's a 0. Just random stuff I'm gonna write here. If it's case 1, we're gonna say print let me go ahead and scroll down here so I just have a bit more room. Print never, don't do it. I don't know, I'm just making things up here. If it's if we get a 2, we're gonna print I don't know, what should we print here? We're gonna say absolutely, definitely should do it. And this is obviously a string, so let me put my quotation here. And for case 3, we're gonna say maybe, hold on, print maybe, but be careful. And lastly, we're gonna do this. We're gonna put a default here, and the default is obviously the last statement, so whatever's left. And I'm gonna say even I'm not sure. And essentially the default will execute for anything else, which will be a 4. Switch statement must be exhaustive. Let's let that be. That should be exhaustive. Perfect. Okay, perfect. So we've done this now. So we've created this magic ball random generator, and we've created a switch statement. Of course, you could have done if statement. Either one would have worked. Okay, great. Now let's go ahead and call the actual function, magic ball. So how do you do that? Well, that's pretty easy. All we have to do is, hold on, we've got an error here. Expected curly brace. Yes, of course. Just give me a second. Okay, so that should fix that. Okay, so let's actually go ahead and let's go ahead and call the magic ball. So magic 8 ball, when we call it, it'll actually randomly pick a number from 0 to 4 and it'll print something, maybe but be careful. Well, maybe but be careful is 3. So the random generator generated number 3. From 0 to 4 generated number 3. So if I go ahead and call it up again, it most likely will generate a different number. So let's see. Never. It said never, don't do it. Okay, so the first time, so it actually Xcode re-executed both. So the first time around, it said never, don't do it. So the random generator got number 1, and the second time said maybe, but be careful, got number 3. If I go ahead and call it up again, let's see what we get this time around. And see what Xcode does, it reruns the whole code all over again. So actually these numbers are being randomized again and again. And of course Xcode and Playground is being funny now, so it stopped on me, kind of froze. Running lab, it shouldn't take this long. So I'm gonna go ahead and file and save. I'm gonna go ahead quit Xcode, and I'm gonna launch Xcode again and run the lab and let this thing run again. We'll see. This happens to everyone here. Let's have a look here. There we go. Simulator's launch, it's running lab. This should only take a few more seconds and we're good. Here it says absolutely, definitely do it. So it got 2, then yes, go for it, which is 0, and then never do it, which is 1. Okay, fantastic. Let's move on to the next page. Okay, so this is the second page here. So, as you may have guessed, functions are key to making your app work. For example, in every exercise dealing with count until now, you have simply assigned a number of steps to a steps variable. This isn't very realistic, seeing the number of steps you take increments one at a time and continues changing throughout the day. A reoccurring process like this is a perfect candidate for a function. Write a function called increment steps after a declaration of steps below that will increment steps by 1 and then print its value. Call the function multiple times and observe the printout. So they've created a variable for us here called steps, and they've initialized it at 0. So we're going to create a function as the lab suggests called increment steps, and let's go ahead and create the function. And it told us that in the function, make sure that the variable steps is incremented 1 at a time. So okay, so steps plus equals 1, that's going to increment it by 1, and then we're going to print steps just like the instructions asked us to do. Perfect. Now all we have to do is actually call up the function, which is increment steps. So if I call this up, it should say 1, or rather, yeah, it should say 1 because 0, and then I incremented it by 1. If I call it up again, it should say 2. And then if I call it up again, you get the idea. It will say 3, and so on and so forth. So every time, for example, if you're creating an Apple Watch app or an iPhone app that keeps steps, every time the accelerometer is moved for a step, whatever that X, Y, Z movement is, you run a function like this and say, listen, add an extra step. Pretty cool stuff. All right. Moving on, similarly, if you want to regularly provide progress updates to your user, you can put your control flow statement, the check on progress, into a function. Write a function called progress update after the declaration of goal below. The function should print, you're off to a good start. If steps is less than 10% of goal, you're almost halfway there. If steps is less than half of goal, you're over halfway there. If steps is less than 90% of goal, you're almost there. If steps is less than goal, and you beat your goal otherwise. So call the function and observe the printout. Remember, you can convert numbers using the appropriate int or double initializers. Okay, so that's a mouthful. Let's go ahead and try to solve this. So they've created a constant for us called goal, and they've set it at 10,000. That's easier to read. So let's go ahead and create the function like they told us, and they called the function, I believe, progress update. Correct. Okay, so we're gonna call this progress update, and we're gonna create the function. Okay, so that's our function right here. Beautiful. So what do we do in the function? Well, we're going to create a simple if statement, right? Control flow. In the previous page I used switch. I'm going to use if statements here. So if steps is less than, well, less than, what did it say here? Less than 10% of the goal. Well, this is an int, and I could do that by holding the option key, if I'm not mistaken, clicking on it, knowing that this is an int. I'm going to convert this to a double because we might not actually be dealing with an int. So int double goal, that's our goal, and we said 10%, so 10% is times 0.1. Okay, great. And so if steps is less than 10% of goal, right? So what I've done here is I've just converted it to a double and back to an int. So if the goal is 10% or less, rather less than 10%, so 9.9999 and less, do the following: print, and they told us to print what? You're off to a good start. So I gotta print that. You know what? Might as well copy and paste it, to be honest. There we go. It's much easier. Great. So else if, let me just go back here. Else if steps is less than, what did they say here? They said 10%, halfway there. So what's halfway? Halfway is 50%, so it's goal divided by 2. That's halfway, right? we're gonna print. I think you're almost halfway there, right? You're almost halfway there. Yeah. Okay, so we're gonna print. You're almost halfway there. Oh, there we go. And we're gonna do an else if here. Else if steps is, what is it? So halfway there, you're over halfway there. If steps is less than 90%, okay, so goals, so we did that, you're almost halfway there. If steps is less than half of goal, you're over halfway there. So we've done that, and you're almost halfway there. You're off to a good start. And then what is it? If steps is less than 90% of goal, you're almost there. Okay. Hold on, I've skipped one. If steps is less than 10%, you're off to a good start. Great. You're almost halfway there if steps is less than half of the goal, which is this thing right here. You're over halfway there if steps is less than 90% of goal. If steps is less than half goal, you almost have the. If steps is less than, you're okay. You're almost halfway there. This is the way it's worded. It's really confusing. Okay, so that's fine. So I'm gonna do this. If steps is less than 90%, I think that's how I interpret it, the way how they're writing it. So how do you do this? Less than 90%. So same thing. Int double um, uh, double goal, and obviously 90% is times 0.9. Okay, beautiful. So we're gonna say 0.9, then it's gonna be, let me just clean this up, your print, what is it? You're over halfway there. Great. And then lastly, so 90%, you're almost there. If steps is less than goal, you beat your goal. Okay, so I think there's two more. Else if steps is less than goal. So essentially here what we're saying is it's over 90% but it's less than goal. So you're anywhere from 90 to 100. We're gonna print you're almost there. You're almost there. And lastly, which is else, well, what else is there? You've actually, it's more than your, like, you've done more than 100%, so you have beaten your goal or something along those lines. Okay, you guys get the idea. So essentially, if it's 10% or less, you're off to a good start. If it's anywhere from 10 to 50%, you're almost halfway there. If it's over 50% but less than 90, you're over halfway there. Sorry, if it's 10% to halfway, you're almost halfway. If it's halfway to 90%, you're over halfway. If it's 90%, if it's less than goal, but obviously the only other option is over 90, you're almost there. So 90 to 100, you're almost there. Anything else which is over is you've beaten your goal. Okay, fantastic. So let's go ahead. That was a mouthful. Let's go ahead and do a progress update because that's what we called our, whoops, progress update. That's what we called our function. So let's go ahead and call our function progress update. And if we do that, you're off to a good start. Well, you're off to a good start. It shouldn't, yeah, it should say that. 10,000 goals 10,000. Well, steps is, yeah. Well, where's our steps? Steps is 0, that's why. Okay, so obviously you're off to a good start because it's less. So if I go ahead and change steps to I don't know, let's go ahead and change steps to 8,999. It should say, oh, I shouldn't say you're off to a good start. It should say, oh, you're over halfway there. Perfect. Right? And if I change it to, let's say 11,000, it should say you've beaten your goal. You've beaten your goal. And if I go, I don't know, 100, it should say you're off to a good start. If I say 6,000, 6,000, it should say you're over halfway there. You're over halfway there. And if it's less than half, so less than half would be like 4,000. It should say you're almost halfway there. Perfect. Okay, this works. Awesome. Okay, let's move on to the next page. Okay, so we've got the next page here, and let's see what it says here. Write a new introduction function called introduction. It should take two string parameters, name and home, and one int parameter, age. The function should print a brief introduction, i.e. If Mary, California, and 32 were passed into the function, it might write Mary 32 is from California. Call the function and observe the printout. So let's see how we would do this. We would create a function using the func keyword. We're going to call this introduction. And we're going to pass on two parameters. The first is called name, and obviously it is of type string. And the second, we could call it home, and it is also of type string. And lastly, age, and it is of type int. And great. So that's our function here. So let's go ahead and write the function. So we're going to say print, and we're going to put in quotations. We're going to escape the quote, and to escape the quote, we do a backslash, and we're gonna say put name in here. So whatever the end user puts, they're gonna put name in there, and then we're gonna do another age here, for example, and so let's say Baram x age, put a comma here, is from, and let's say home, and we're gonna do this. So is from home, and dot, and let's close the quotation. Okay, so what we've done here is we've created a function called introduction, and when you call up this function, you have to give it a value of string under name, a value of home, a value of string under home, and a value of age, a value of int, which is under age. So these are the three parameters: name, home, and age. And the function prints out name. So let's say John of age 30 is from, and then you write home. So if you put Toronto for home, name John and age 30, it would say John, comma 30 is from Toronto. So let's go ahead and call up the function. So introduction, and Swift automatically tells you, listen, there's three parameters, you need to fill them out. So string, we're gonna put param, home, we're gonna put Toronto, well, it's a string type, Toronto, and age, we're gonna put 30. And that's it. And now it should work. Undetermined string literal. Oh, of course. There we go. This should work. There we go. Baram 30 is from Toronto. Okay, pretty cool. Okay, let's move on. Write a function called almost addition that takes two int arguments. The first argument should not require an argument label. The function should add the two arguments together, subtract 2, then print the result. Call the function and observe the printout. So let's go ahead and do that. So we're going to create a function called, well, we start by writing the keyword func. and it's called almost addition. And the first, see, they give you specific instructions here. The first argument should not require an argument label. Well, if you don't write an argument label, you simply put an underscore. Same with the loops, for loops. If you don't actually use the index, you put an underscore in Swift. The label's called the first parameter. The first argument is first number, and it's of type int. And the second number, let's lowercase the s. Second number is of also of type int. Let's just see, write a function almost addition that takes two int arguments. The first argument should down and the function should add. Okay, perfect. Okay, so that's it. So it's a simple function that just takes in two int arguments. But the first one I put an underscore here because um, um, the argument label won't need to be called. You'll see what I mean in a sec if you're not understanding this. So let's actually write the function. So print its first number plus second number minus 2. The function should add the two argument together, subtract them by 2, then print the result. Okay, that's exactly what we want. Okay, so we've done this. This is all good, I think. So let's go ahead and call the function almost addition. There we go. So the first, it tells you that it's first number, but you see how the whole thing is highlighted? As soon as I put a number, so let's put number 30. The argument label, which is first number, it doesn't show. The second number label needs to be put here. If you don't put this, it won't work. So let's go ahead 20. The result should obviously be 30 times minus 20 is 10 plus 30 plus 20 is 50 minus 2 should get 48. And yes, we did get 48 right here. So it looks like this because of that underscore. That underscore says, listen, that first label doesn't need to appear here. That's what that means. Perfect. Okay, so we're almost done here. Let's see what they want us to do here. Write a function called multiply that takes two double arguments. The function should multiply the two arguments and print the result. The first argument should not require a label, and the second argument should have an external label by that differs from the internal label. Call the function and observe the printout. Okay, so let's see what we're gonna do here. So func, and we're gonna call this multiply. And since the first label is not required, we put an underscore first number, and it is of type double. Great. The second is by second number, and it is of type double as well. And let's go ahead and do this. Okay, so let's see what we do here. Should not require a label, and the second argument should have an external label by. Okay, that's fine. So it's just an external label. We put that in here, and the function is gonna print first number, and all we're doing is we're multiplying it by second number. That's a pretty simple thing to do. Let's go ahead and call it. So multiply first number, let's say first number is a 10. The second number, let's say by 4. And obviously we should get the answer being 40. Use of unresolved identifier second, of course. It's called second number. This should work now. There we go, 40. Obviously it's double, it's not 40, it's 40.0. So here, if you wanted an external label called by, it would say by as opposed to second number. So this is called an external label. And that's what we just did here. Great, so let's move on to page 4. Okay, so this is page 4. In many cases, you want to provide input to a function. For example, the progress function you wrote in the functioning app exercise might be located in an area of your project that doesn't have access to the value of steps and goal. In that case, whenever you call the function, you would need to provide it with the number of steps that have been taken and the goal for the day so it can print the correct progress statement. Rewrite the function progress update, only this time give it two parameters of type int called steps and goal. Respectively, like before, it should print you're off to a good start if steps is less than 10% of goal. You're almost halfway there. If steps is less than half your goal, again, this whole thing again. Okay, 90%, you beat your goal, got it. Otherwise, call the function and observe the printout. Call the function a number of times, passing in different values of steps and goal, observe the printout, and make sure that what is printed to the console is what you would expect for the parameters passed in. So essentially, we're going to be doing the same thing that we did previously. The only thing is we're going to pass in functions. So we did this previously here. Let me just go back. No, we didn't do it here. It was page 2. So we're going to redo this, except we're not just going to have a passive function like this. We're going to have parameters in here. Okay, so let's go ahead and give this a try. Actually, you know what? I'm gonna make my life a whole lot easier because this thing is identical. So I'm gonna copy this and I'm gonna paste it here just in a second. Let's go ahead and create the function first. So func, there's a whole bunch of errors. These will disappear hopefully. Progress update, because that's the name of the function. Progress progress update. Yeah, I'm pretty sure it's called progress update. Yeah, it's right here. Progress update. And instead of having it being no parameters, we're actually going to pass some arguments on here. So the first is steps of type int, right? And the other is goal of type int. Great. Goal of type int as well. That's awesome. And now we create our function. And inside our function, we essentially cut and we paste this function right here. Beautiful. So this is our function right here. It's pretty much identical to the previous function that we did, except the only difference is this part right here. We actually could pass in integer values. So let's go ahead and call the function and let's see how this works. So progress update. Now when I call the function, it's asking me, listen, you gotta put two ints, one for steps, one for goal. So for steps, I'm gonna put, let's say, I don't know, 54. So we just started off and the goal is 10,000. And let's call this up. You're off to a good start. Obviously that makes sense. If I call the function again, right, and I put, let's say, that was less than 10%, more than 10%, but less than half. So let's say 2,000, for example, and we set the goal as 10,000 again. I'll say you're almost halfway there. You get the idea. If I go progress, update, call the function again, and I type in 13,000, for example, and the goal is only 10,000. Of course, what you're gonna see here is you've beaten your goal. All right, that's beautiful. That was pretty easy, right? Okay, let's move on and do page 5. Okay, so page 5. Let's have a look here. Write a function called greeting that takes a string argument called name and returns a string that greets the name that was passed into the function, i.e. if you pass in Dan, the return value might say, hey Dan, how are you? Use the function and print out the result. Okay, pretty easy stuff here. So func to create the function. We're going to call the function greetings, or just greeting. No need for an S. We're going to pass a argument called name of type string, okay? And it's gonna return a string. Great. Let's do this. Okay, so what are we gonna do here? I'm gonna say return right? So this tells me this returns something. So we need to actually put the keyword return here, and we're going to return hi. Gonna escape the quotes here. Put function name, and so let's say hi John. I don't know. Let's be unique here. Hi. So hi John. Do you want to be my best friend? Okay, sure. Okay, so that should work here. So let's go ahead and print the greeting. Print, oh, sorry. Print greeting, and it's gonna say, listen, you have to provide a value here for the argument, and it's of type string. So I'm gonna say, I'm gonna give it the value John. So when I print the greeting, it's going to say, hi John, do you want to be my best friend right here? If of course I change this to Jennifer, it'll say the same thing here except hi Jennifer. So this returns something. It returns a string to be more specific. Okay, great. So write a function that takes two int arguments and returns an int. The function should multiply the two arguments, add 2, then return the result. Use the function and print the result. Okay, so essentially we're doing the same thing that we did up here, except with integers as opposed to strings. So let's see how we would do this. Func, write a func. What is the name of the function? Oh, they don't tell us the name. All right, so I'm just gonna call it whatever. Multi. Just gonna call it multi. So func multi, and it's gonna have a first number, and that's obviously of type int. And it's going to have a second number of type int as well, and it has two arguments. Okay, okay, that's fine. And it's going to return an int, obviously, so it'll return an int. Okay, great. So what do we do here? So we're going to say return first number. The function should multiply the two. Okay, so first number times second number, and add 2. Okay, plus 2. Okay, easy peasy. Okay, let's go ahead and call the function here. Now to call the function, this is tricky. So here with it's not tricky, but with a string you could just see the result by printing the string. I guess I could print the number as well, or I could save it in a variable or a constant. So watch, if I create a variable, I should probably create a constant. It's not going to change. Constant. I'm going to call it temp number, just somewhere to store what's being returned here. Okay, and I'm going to say multi, right? I'm going to return multi. Let's see here. Boom. So it's going to say first multi has two parameters. Please provide integers for them. So I'm going to put 20 and I don't know, 3. So if I do that and I go ahead and print temp number, it should print the number 62 because 20 times 3 is 60 plus 2 is 62. So what I've done is I've actually called the function right here. Whatever return it gave me, I stored it in this constant called let number, temp number, sorry, and I printed temp number. Yeah, that's pretty much it. Okay, moving on to the last page. Okay, so let's look at the last page here. One principle that can help in debugging and maintaining code is abstraction. For example, in your fitness tracking app, some of your existing functions have been written to both perform a calculation and print a message. But it's very possible that you'll decide to change either the calculation or the message in the future. It will be easier to go back and change this if you separate the calculation from the message. As an example, write a function that only does a portion of what your previous pacing function did. This function will be called calculate pace. It should take 3 double arguments called current distance, total distance, and current time, and should return a double that will represent the time at which the user will finish the run based on the user's current distance and time. Call the function and print the value. Okay, let's see how we would do this. So I'm going to create a function called func, and they told us to call it calculate pace, right? So like this is a running app, and it's supposed to have how many? 3 if I'm not mistaken, right? Pacing. The function will calculate pace. Let's have a look here, but it's very possible. Okay, so 3 double arguments. Okay, great. 3 double arguments. The first is called current distance, and it's of type double. The second is called total distance, and it's also of type double. And the third is called current time, also of type double, and it's supposed to return a double, correct? And that's pretty much the function. And when we return, it's supposed to return the pace, which will represent time, and should return a double that will represent the time at which the user will finish the run based on the user's current distance and time. So when will the user finish the time? Well, let's do some simple math. It's current time divided by current distance, divide that by total distance, correct? So current distance divided by total distance, current time divided by current distance. Yeah, I think that should work. Let's go ahead and call up the function temp value. Let's call it up, calculate pace. Great. So it's asking for 3 variables here. So current distance, let's say you've ran 100 kilometers. Total distance, let's say it's 200 kilometers, and your current time, let's say it's you're 5 hours in. And let's go ahead and print temp value, and it should give us a value of 10. Why? Well, current distance is 100, total distance is 200, current time 5. If you do the math, it should be 10. Okay, great. Now write a function called pacing that takes 4 double arguments called current distance, total distance, current time, and goal time. The function should also return a string, which will be the message to show the user. The function should call calculate pace passing the appropriate values and capture the return value. The function should then compare the return value to goal time, and if the user is on pace, return keep it up, and return. You've got to push it just a bit harder, otherwise call the function and print return value. Okay, so let's see how we would do this. So we're going to call this pacing, and we're going to go current distance of type double, total distance of type double, current time of type double, and goal time of type double, and we'll also return at double. Okay, great. That's fine. Let's return passing in appropriate values and capture the return value. Okay, so what are we going to return here? Well, we're actually going to return, hold on. The function should also return a string. Also, we're returning a string. Return a string which will be the message to show users got it. Okay, so we actually have to create a simple if statement here. So if pace is equal to or less than goal time, then we return keep it up, right? Else we're gonna return you've got to push it just a bit harder. Okay, that should work. Um, yeah, I'm missing a curly brace right here, aren't I? That's for this and that's for this. Perfect, and this is for that. Great, use of unresolved identifier pace. Of course, I have to create the formula. Let pace equal calculate pace and current distance be current distance, total distance be total distance. So what I'm doing here is current time be current time. So what I'm doing is I'm using the variables. So these are the parameters. Instead of actually putting a number, I'm using what I've put up here, which is 100, 200, and 5. Okay, this should work now. Cannot convert return expression of type string to return double. Interesting. What did I do here? Return. There we go. Okay, this should work now. No, cannot convert return expression of type string. Oh, interesting. Cannot convert return expression of type string to return type double. Of course, of course, of course. We're returning a string, not a double. Silly me. This should go away in a second. There we go. Okay. And returns 10 up here. Goal time, what was my goal time here? Goal time is double. Current time. Function pacing. Okay. Okay, I think this is perfect. I've got no errors. Okay, so all we have to do now is call up the function pacing. And when we call it up, let's put some numbers here. Let's put, again, current distance. Let's say it's 100 kilometers of 200 kilometers. Your current time being 5 hours. And the goal time, I don't know, let's put like 8 hours. Let's check this out. And you've got to push a bit harder. If I actually print pacing, whatever, I could print pacing, but I could go let equals let temp value equal pacing and print temp value, but it's the same thing. Invalid redeclaration of temp value because I've already declared it up there. So it should say you've got to push a bit harder, which is right here. Why? Because the math says, well, the math would be, it's, well, what is it? It's actually less, right? So if I change this to 12, for example, keep it up, right? So all it is, it's not half, right? So you're halfway there, but you're doing better on time. If I change this to like 7 again or 8, it should say you should push harder because you're a little behind. But obviously, if I change this to a larger number, it'll say you're on track. Keep it up. Anyways, that's not the point of this exercise. The point of this exercise is to be able to return a string when the thing is doubles, and kind of getting used to returning things from a function. Okay, hopefully you've enjoyed this lab. I know it's a bit longer than it should have been, but anyways, feel free to comment and ask any questions about this last part or any part for that matter. Thank you for watching.